Next up is free radical halogenation. Alright, so free radical halogenation is probably one of the most important, if not the most important reaction for the MCAT. Luckily for us, it's probably the easiest reaction we'll ever have to know. Alright, so pretty much what it is we have this straight chain alkane. All we're doing is we're adding a halogen, so X is a halogen, so it could be something like Cl2, and we're using HV, which is light. Okay? And what it's doing is it's going to just add that halogen onto the alkane molecule, like this. Okay? And notice how I put the halogen on the secondary carbon. I could have put it on the primary carbon, but I didn't. And the reason why is because reactivity of free radical halogenation is tertiary is greater than secondary is greater than primary. That means we are more likely to have a secondary free radical halogenation in opposed to a primary. That being said, we will still have some primary halogens being added, but in a lot less of a proportion in comparison to the secondary. That's why the secondary halogen is going to be our major product. And that's all that's important for the MCAT, knowing the major product. Right? So remember this: tertiary, secondary, primary. Right? So there's 3 steps in the reaction mechanism, and it's initiation, propagation, and termination. Alright, so we're just going to go over the basic of what each of these steps are. So first off is initiation. So what happens in an initiation is we have our molecule like this. Okay, so this X we're going to treat as Cl's. Okay, so we have these Cl molecules like this. Okay, and what's going to happen is we're going to have a radical, or each electron is going to go into each of the different halogens. Okay, so what we're going to form is X radical and X radical. Notice I only drew these half arrows because there's 2 electrons here. Only 1 electron goes to each of them. Okay, that's why we form these radicals. Okay, so what we're going to do next is we're going to get these radicals and we're going to react them with our original compound. So what I draw on here is just that same butane molecule, but I drew the H so we can see what happens to it. So what happens is one of the electrons is going to go onto the carbon molecule, and one of the electrons with the H is going to react with this X halogen that we created, or X radical that we created in the initiation step. So what we're going to form is this butane radical, and if you guessed it, it's going to be H and X. So for example, HCl. Okay. So now what we're going to do is we're going to react this molecule, this butane radical, with our original Cl2 compound. Okay. So what's going to happen here is, similarly to before, we're going to form our molecule. Right? And we'll also have this radical at the end. So notice how we always go from one radical to one radical, one radical to one radical in propagation. They're just switching. Right? It's switching from the butane molecule now over to the halogen. So that's what propagation is all about. And notice that was our final product. Alright, so we created our final product. So what's the point of termination? Well, the point of termination is we have all these radicals floating around. What do we do with them? Well, we have to react them together because otherwise they'll damage the ozone layer, and it'll be very, very bad. So what happens is all these radicals just react with each other. And this R that I drawn here is just the butane radical. So they'll just react together and they'll form this very big alkane molecule. So all we're doing in termination is kind of sweeping up everything, cleaning up everything, so getting rid of all the radicals. So just to recap, what we've done here is throughout the initiation, propagation, and termination, all we did was react this butane molecule with these halogens and light, and we created the haloalkane. Okay? But there's one more step that we need to know, and it's in terms of stereochemistry. Remember, for all these reaction mechanisms, stereochemistry is very, very important, because it could be the different. You may know the actual compound that is formed, but is it R or is it S? And that'll make a difference because it's multiple choice on the MCAT. Right? So if we look at this, what actually happens is we form this radical, right? Well, this radical is now sp2 hybridized. Okay? There is no preference. There's no preference for whether or not it's going to be forward or backwards. It's just going to be trigonal planar 120 degrees, and you can either attack this X halogen in the front or you can attack it from the back. Therefore, the actual thing that we're going to create is going to be a racemic mixture. So remember this term, racemic. Racemic means we are going to have a 50% of the R and 50% of the S. So that's what it means, okay? So free radical halogenation is always going to create a racemic mixture, okay? And that's for the reason that, you know, it's sp2 hybridized for the radical. Radicals form sp2 hybridized carbons, and that's the reason why we're not going to have any preference over R or S.